In this video, we're continuing our factoring series, and we're going to talk specifically about how to factor when there are only two terms. So you can have a plus or a minus sign, but on either side of those, you're going to have two terms. Like this one has a minus, right? We have a term on one side and the other. Same thing over here, we have a plus with one term on either side of that plus sign. Now, this kind of gets grouped into two different sections, usually, all right? There's a couple other examples, but for the most part, you're either going to be able to take out a GCF, or a greatest common factor, or the other type is it's going to be probably a difference of squares. So we're going to look at both examples today. Let's get started. All right, so the first type we're going to look at is going to be one that just has a GCF. Now, what does that stand for? It stands for a greatest common factor, meaning that in all of my terms, I have something that can go into, whether that's a variable or a number, something that can go into all of those terms. For example, this first one here, it says p squared plus 17p. Well, first thing I'm looking for is numbers. This one doesn't have any numbers in front, no coefficients, if you will. And so then I have to look at the variables. I'm seeing that they both have a p that I can take out. This has two p's, this has one p, if you want to think of it kind of that way. So I'm going to take out that single p, and left on the inside, kind of my leftovers, is going to be p plus 17. All right, now this is fully factored. And because it only had a GCF, that's all you can really do with it. The second one, we can start with a number this time. This has an 8 and a 16 as my coefficients. So what number goes into 8 and 16? The biggest one, the greatest common factor? Well, 8. 8 goes into both 8 and 16, so we can take an 8 out. And then they also have an x in common as well, so I'm going to take an 8x. If I do that, what is 8x squared divided by 8x? One way to think about this, if I have 8x squared, that's like x times x, and then divided by 8x, well, the 8's and the x's are going to cancel, and I'm just going to have one x left over. So here I'm also just going to have one x left over. And then if I divide the same thing, negative 16x divided by 8x, negative 16 divided by 8 is negative 2. X divided by x, of course, cancels. And so I think this would be my factored solution. All right, one last one here. What if they give us an equal sign? This one looks like there's more than two terms at first, but if I do a little math, if I subtract, oops, not 2, how about 5? If I subtract 5 on both sides, then all of a sudden you're going to see that those both cancel, leaving me with 6n squared minus 6n, and equals 0. So the two terms are my 6n squared and minus 6n, right, equals 0. This is one where we can solve by factoring because equal to that 0. And what do those both have in common? They both have a 6n. So I'm going to take out 6n, leaving me with just an n. Then what about this one? I took out everything. I took out the 6 and the n. So what is negative 6n divided by 6n? It's just going to be a negative for the sign, and then a negative 1, right? 1 times, if I were to think about distributing this back in, 1 times 6n gives me 6n. So I'm going to take out a 1. Now this is 1, because it equals 0, you can actually solve it. And I'm going to say both of these parts, the 6n, I'm going to set that equal to 0, and the n minus 1. N minus 1 equals 0. Here, if I divide by 6, 0 divided by 6 is still 0, so n is going to equal 0. In that one, if I add 1 on both sides, I get n equals 1. So this one actually has answers because there's an equal sign. This one, they're just going to say that those are the factors, right? Let's try our other type with two terms. The second type of factoring that we have when it comes to just having two terms is called difference of squares. Now, that word difference here means subtraction. So all of these, you'll notice, have a subtraction sign when it comes to the problems that we are given, all right? Now, what we do with this actually is a result of kind of two factors that if I were to multiply these back together, what actually happens is you take the square root of m squared, and of course the square root of m squared is m, and that first square root is going to go in the first part of our factor. The second part is going to be the square root of our second number. Square root of 9 here is 3. So I chose kind of nice ones because typically these are the ones you see on your assignments. And so we have m and 3 and m and 3. Now the signs that go in the middle here, we're going to have a plus and a minus. And that actually is the answer to this problem. If I were to distribute this back in and say m times m is m squared, right? M times negative 3 is negative 3m. Oops, m squared minus 3m. 3 times m is 3m. And 3 times negative 3 is a negative 9. Because of this, these middle ones cancel, and you're left with just the m squared minus 9. So if I kind of multiply those back together, I end up with what I originally started with. So the factors of this are just m plus 3 and m minus 3. So if you know that kind of shortcut, if you will, it makes these problems a little bit faster. All right, what about this one? So again, I'm going to start with my two sets of parentheses because I'm noticing that 81 and 121 are both perfect squares. All right, also x squared is a perfect square because it's x times x, or x squared. And what is the square root of 81? Well, it's going to be 9. And the square root of 121 is going to be 11. So I'm going to put 9s first and then 11s. And then also, this one has an x squared with it. So I need to put the x with the 9 as the x squared is with the 81. And just like before, I'm going to put 1 with a plus sign and the second one with a minus sign, just like that. So this is going to be 9x plus 11 times 9x minus 11. All right, this last one's going to be a little bit tricky because we can do it twice. And here it says x to the fourth minus 16. So if I follow that same pattern that I've been doing with my two sets of parentheses, x to the fourth, if I take the square root of that, it's actually x squared. So x squared and x squared. And then the same thing with 16. The square root of 16 is 4. So 4 and 4, but one with the plus and one with the minus. However, I'm not done. If our directions on this, which usually the directions on these types of problems are factor completely, if it says to factor completely here, this is not factored completely. The second part is another difference of squares. So I can bring down my first one exactly like it looks. However, the second part, x squared, it is also going to be if I take the square root of it, I get x and x, so it's also a difference of squares here. Same thing with the 4, it's going to be 2 and 2 with a plus and a minus. And then like I said, if I bring down my x squared plus 4, this one is not a difference of squares, but difference means minus. So this is a plus right there. And so it's just going to stay as x squared plus 4. So this one kind of ends up with 3 factors when you go ahead and do that difference of squares. All right, guys, hopefully this helped you out. And also, if you're looking for more factor problems, or maybe you're factoring by grouping or factoring with the GCF or something like that, you can check out this video right here. And until next time, keep doing your math homework fast and accurately.